Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology, Jamaica, and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today, we will be looking at Module 1, right, which is Complex Numbers and Calculus 2 in the CAPE Pure Mathematics Unit 2 syllabus. And the topic is partial differentiation, all right? So we have a question here which says if f of xy is equal to x squared plus xy plus y squared, determine fx of xy and fy of xy. And we have a follow-up question which says hence show that fx squared plus fy squared is equal to 5f plus 3xy. All right, so let's do that question. So part 1, we need to find fx of xy. All right, this basically means that we're going to differentiate f partially with respect to x. All right, meaning that we're going to differentiate all the x terms and keep y as a constant. All right, we're going to treat y as a constant. So when we differentiate x squared, we get 2x. Right, the derivative of x squared is 2x. Plus, if you differentiate xy with respect to x, right, you will get y. All right. If you differentiate y squared, remember y squared is a constant, so you will get 0. So we don't need to write that. All right. So we have finished finding the partial derivative of f with respect to x. Now we need to find the partial derivative of f with respect to y. All right. So what we're going to know is differentiate all the y terms, right, with respect to y and keep x as a constant. So we're going to treat x as a constant in this case. So when you differentiate x squared, you should get 0. When you differentiate x, y, right, what you get is x. Right? You're differentiating with respect to y, right? So you get x. Plus, if you differentiate y squared with respect to y, you will get a 2y. All right? So those are our answers for part 1, and we have successfully completed it. Now we'll be looking at a follow-up question, part 2, which says, hence, show that the partial derivative of f with respect to x squared plus the partial derivative of y with respect to the partial derivative of f with respect to y squared is equal to 5 times the function plus 3xy. So let's do that here. Part 2 solution. All right. So we're going to look at the partial derivative of f with respect to x squared plus the partial derivative of f with respect to y. All right, we're squaring that. Okay, so we know that the partial derivative of f with respect to x is 2x plus y, and we're squaring that. So that's going to be equal to 2x plus y squared, right, plus the partial derivative of y, the partial derivative of f with respect to y, sorry. So that's going to be x plus 2y, and you're squaring that. All right, let us expand the brackets. So if you expand, you should get 4x squared plus 4xy plus y squared. All right, plus if you expand x plus 2y all squared, you will get x squared plus 4xy plus 4y squared. All right, let me go over a bit. Let's go over a bit. Good. So plus 4y right here. 4y squared. Okay. And that is now equal to 4x squared plus x squared will give me a 5x squared. All right. Plus the 4xy plus the 4xy will give me an 8xy plus y squared plus 4y squared will give me a 5y squared. All right. So I hope you see that. Let me scroll down. Now remember the axis to show that we're going to have 5 multiplied by the function f of xy plus 3xy. So that's what we need to show. So we need to manipulate this expression here, and so that we can show that it is 5 times the function plus 3xy. So this is what I'm going to do. I will have 5x squared, and I'm going to split the 8xy, right? I'm going to split the 8xy into 2 terms, which will be 5xy plus 3xy, right? And I have the plus 5y squared at the end. Good. So what can we do now? What I'm going to do is bring all the terms together that has the 5 in it. So I will have 5x squared plus 5xy plus 5y squared plus 3xy. All right, so we're one step closer to our answer. So what we need to do at this point is to factor out the 5 in all 3 terms, right? The first 3 terms. So if you factor out the 5, you will get x squared plus xy plus y squared plus 3xy on the outside. All right, and now if I go back up, remember the function f of xy was x squared plus xy plus y squared. All right, that was the function that they gave us. So if you look inside the brackets, that is exactly what we have, right? X squared plus xy plus y squared. So this is now equal to 5 times the function f of xy plus the 3xy. All right, so they asked us to show that the left-hand side is equal to 5 times the function f of xy plus 3xy, and that is what we have here. All right, we have shown what they have asked us to. So I will now write shown. All right, and we are now finished. So we have successfully answered part 2 of the question. All right, so this is partial differentiation of the CAPE Pure Mathematics Unit 2 syllabus. I'm Mr. Garth Reed, Student Ambassador for the University of Technology, Jamaica, and Mathematics Teaching Training in the School of Mathematics and Statistics. I thank you for joining.